Hello and welcome back, dear students. Today, from the equilibrium concept, we are going to discuss about the Lee Chatelier's principle. It is the important part of equilibrium chapter, and we are going to discuss about the Lee Chatelier's principle. What is Lee Chatelier's principle? Basically, it is used to increase the production in industry. This concept is used to increase the production of anything, because from the chemical reaction what we are doing the production. Suppose any reaction is given, N2 plus 3H2, very famous Haber process, and 2NH3. From this reaction, this system is in equilibrium. Equilibrium means, children, when you started the reaction, whatever amount of nitrogen and hydrogen you have taken, that is reactant, when ammonia will form, that is your product, so immediate dissociation of ammonia started. Whatever ammonia is formed here, first step, when ammonia start forming, it will start dissociation also into nitrogen and hydrogen. But in the industry we need ammonia. Then how will you collect ammonia? So in that case, Lee Chatelier's principle will help to increase the production in industry. So basically it work in which kind of reaction? Reversible reaction. It will work in reversible reaction, because in reversible reaction only equilibrium establish. Equilibrium only establish in which kind of reaction? Reversible reaction, not in irreversible reaction. So how can you increase the production in that case? That we are going to discuss. How many ways are there? So first case, change change the concentration. Change the concentration means, children, that means number of mole. Change in concentration means what? Change in number of moles. Concentration means amount. So if you are changing the amount, then production will be increased. So in this reaction only, this is the example we have taken. For this reaction, how can you increase the production? Suppose in this reaction, whatever ammonia produce, you remove that ammonia. Remove means from here you taken out. Then what happened? If you do this, then equilibrium disturb. If equilibrium disturb, then what equilibrium want? Equilibrium want undo the change. Undo means whatever change you applied, it want undo. So how it will be undo? If you remove ammonia, what it means? You decrease the concentration of ammonia. Then equilibrium disturb. So what equilibrium want? Equilibrium want increase the concentration of ammonia. Then equilibrium will shift. Equilibrium will shift. How equilibrium will increase the production of ammonia? More amount of ammonia will formed by N2 and H2. So that means forward reaction, fast forward reaction happen and concentration of ammonia increases. So equilibrium shift in which direction? Forward direction. So like that, more amount of ammonia you can produce. Second thing, if N2 concentration increase, that means you increase the moles of N2 in the reaction, then what equilibrium want? Equilibrium want to decrease the concentration of N2. So how it will be decreased? Then again, equilibrium shift. How concentration of nitrogen will be decreases? More, it will work more and more amount of ammonia will formed. Then equilibrium shift in which direction? Again, forward direction. If equilibrium shift in forward direction, then only production of ammonia increases. Similarly, you can do for hydrogen also, same procedure. But in case if you decrease the concentration of hydrogen, then what happen? What equilibrium want? Equilibrium want increase the concentration of hydrogen. Now tell me how concentration of hydrogen increase, children? By the dissociation of ammonia. Then equilibrium shift this time which direction? Equilibrium shift in backward direction. That means less production of ammonia. Equilibrium shift in backward direction. So that is the concept. One more example we will take. Suppose this reaction is given 2SO2 plus O2, it is forming 2SO3. So question is how to increase the production of SO3. Production increase. So production of SO3 increased by, children, when equilibrium shift in forward direction. So in which condition equilibrium shift in forward direction? So first condition is, if you removed SO3, SO3 remove, from here take out SO3, then equilibrium shift in which direction? Equilibrium shift which direction? Forward. Second thing, you can increase the concentration of SO2 or O2. Then also equilibrium shift in which direction? Forward direction. Like that, production will be increased. So that is the first case, change in concentration. That means you are changing the number of moles. Got it? Very good. Now come to the second part, second point for this. Second point is change in pressure. If you are changing pressure, so first I am telling you the rule, then I will explain also how it will be. So rule is, if you increase pressure, equilibrium shift to that direction which has less number of moles. Equilibrium shift, if you increase the production, increase the pressure, then equilibrium shift in which direction? Which has less number of moles. So example, N2 plus O4, it is forming 2NO2 gas. So if you increase the pressure in that case, then equilibrium shift in which direction? Here 2 mole, here 1 mole. So here number of mole is less, so backward direction. Similarly, N2 plus 3H2, 2NH3. Here if you increase the pressure, then here also equilibrium shift. Which direction? Here 2 mole and here 1 plus 3. Total mole 4. So equilibrium shift in forward direction. So maximum production of ammonia, if you want, then you can increase the pressure also, then maximum amount of ammonia will be formed. So what is the concept behind it, children? Check it. What happened if you increase the pressure, then what happened? Volume decreased. We are assuming that temperature constant. So at the constant temperature, if you are increasing the volume, increasing the pressure, volume decrease. Volume decrease means, children, number of moles upon volume increases. That means it is a concentration. What it is? It's a concentration. If volume decreases, then concentration increases. Think about it. It is an important point here. What I am saying, if you increase the pressure, that time volume decreases. Although there is no increment in the number of moles, but if volume decreases, the number of moles, what is this? Concentration is what? Number of moles per unit volume. Number of moles per unit volume, that is the concentration. So if volume decreases, that means same number of moles are present, number of moles not increases, but they feels like volume compressed. Then more number of that means concentration is what? Number of moles per unit of volume. So if volume decreases, then number of moles increases. Although there is no increment, no increase in number of moles, but it is concentration increases. Number of moles per unit volume increases. That is why I am saying concentration increases. So what equilibrium want? Equilibrium want to decrease this concentration. If concentration increases, then equilibrium want to decrease the concentration. Then equilibrium shift which direction? Where less number of moles there, less number of moles. So that is the concept behind the rule. Once again I am saying, if you increase the pressure, then volume decreases. Volume decreases, that means concentration increases. Why concentration increases? Because number of moles per unit volume increases, that is why concentration increases. Then equilibrium want to decrease the concentration. So equilibrium shift in which direction? Where you have less number of moles. That is the concept here, and that we know the rule why it is pressure is inversely proportional to volume. That is the concept behind this. Suppose PCl5, PCl3, Cl2. If you increase the pressure, then equilibrium shift which direction? Where you have less number of moles, here 1 mole and here total mole is 2, so backward direction. Got it? More example. Okay, next example is important. It is given N2 plus O2 gas, and it is forming 2NO gas. Here if you increase the pressure, then equilibrium shift. Which direction? Here also. Now problem, here also 2 mole and here also 2 mole. In that condition you have to find out delta Ng. G for gas, only we are talking about gaseous moles. So moles of product minus moles of reactant. So here 2 minus 2, in that case 0. So if delta Ng, gaseous moles, change in gaseous moles is 0, then there is no effect of pressure. No effect of pressure. That you have to keep in your mind. Here this system, this is for gaseous only. Similarly, H2 gas plus I2 gas is forming 2HI gas. Here also delta Ng 0, then no effect of pressure. If you are increasing or decreasing, equilibrium will not shift. So that is the concept behind it. Hope you are getting it. One more concept I will tell you. Here we know that PV is equal to nRT. So pressure is directly related to number of moles. Total pressure is directly proportional to N total number of moles. So what happened if you increase the pressure? Then what equilibrium want? Equilibrium want decrease the pressure. Then which direction it will shift? Towards lesser number of mole. Towards lesser number of moles. See, if pressure increases, then what equilibrium want? Equilibrium want decrease the pressure. That means undo the change. So N total will decrease. So where you are having less number of moles, equilibrium shift in that direction. So if first concept you are not getting, then second you can go to this concept also. So that is all about the pressure. Now come to the next point number 3. What is the point number 3, children? Temperature. Total 4 points are there, and in the same lecture we'll finish all these Chatellier's principal concept. Okay, so now pressure is completed. Come to the next part, that is temperature. Change in temperature. Third point. Change in temperature. So what is the rule? If you increase the temperature, then equilibrium shift to that direction which proceed with absorption of heat. See what I am saying. If you are increasing the temperature, equilibrium shift in which direction, which proceed with absorption of heat. Absorption means it is taking heat to complete the process. These kind of reactions are what? Endothermic reaction. So which reaction will be endothermic? In that direction equilibrium will shift. Suppose A plus B plus heat D. So here if you increase the temperature, then equilibrium disturb. If equilibrium disturb, then equilibrium will shift which direction? Forward direction. Why forward, children? Check it once. Here this process A plus B is taking energy and then C plus D formed. Yes or no? It is taking energy, then C plus D formed. So equilibrium, which reaction is endothermic? Forward reaction. A plus B plus energy and it is forming C plus D. So this forward reaction process is endothermic. So equilibrium will shift in forward direction. If opposite you will see here. So C plus D, it is forming A plus D and energy release. Energy release here in backward direction. So that process is exothermic. So equilibrium shift which is endothermic, forward direction. Simple. Second example, it is given H2 plus I2 2HI plus 3000 calorie. So if you increase the temperature, then equilibrium shift which direction? Check it here. Which is endothermic? Here energy released in forward direction, energy release. But in backward direction, when HI is dissociated into H2 and I2, that time this much energy is required. So equilibrium shift in which direction? Backward direction. Hope it is clear to you. More example, in 2 plus 3H2 2NH3 minus 22.4 kilocalorie per mole. Now how can you write N2 plus 3H2 plus 22.4 kilocalorie and 2NH3. So if you increase the temperature, then equilibrium shift in which direction? Which process is exothermic? Endothermic. Here this N2 and H2 is taking heat, then ammonia is forming. Then which direction? Forward direction. So if you want to form maximum amount of ammonia, then high temperature is required, because on forward direction ammonia will be formed. So in this process heat absorbed, endothermic reaction. Got it? Number 4 point, addition of inert material. Inert means what? Which do not react with reactant or product, that is called inert material. So what happened in that case? Oh, in that case, children, 2 points are there. Constant volume, in constant volume, no effect. Constant pressure, equilibrium shift, which has more number of moles. Equilibrium shift in which direction? Which has more number of moles. Example, PCl5, PCl3 and Cl2. So first condition, at constant volume, no effect. If you are adding inert material, then no effect. Second point, at constant pressure, equilibrium shift, which has more number of moles. So in this side 2 moles are there and here only 1 mole. So equilibrium shift, which has more number of moles than forward direction. Equilibrium shift in forward direction. Next example, N2 plus 3H2. Here also, first case, no shift. Second, constant pressure. Here 2 mole and here 4 mole, then backward shift. What is the concept behind it, children? If you are adding inert material, then what happens? That number of moles are not participated. You can say number of moles participate. Whatever number of moles are participating in the reaction, that will not increases. Because it's inert material, it is not reacting with reactant or product. But children, what happened? Total mixture volume. What about total mixture volume? That will be increases, because if you add inert material, total mixture volume increases. Total mixture volume means what? Total mixture volume means what? Number of moles upon volume, that is concentration. So concentration decreases, means volume, the total mixture volume increases, then concentration decreases, because volume increases and same number of moles present in that volume, so concentration decreases. So what equilibrium want? Concentration decrease. Then equilibrium want undo the change. And how it will be undo? That means equilibrium want increase the concentration, number of moles upon volume. Equilibrium want increase the concentration, so where it will shift? Which have more number of moles, it will shift more number of moles. More number of moles, that is the concept. Once again I am saying, number of mole participated not increases but mixer volume increases, that means concentration decreases. Then equilibrium want undo the change, so it want to increase the concentration. How will be increased? Where you have more number of moles, that's it. So these are the 4 points of Lee Chatelier's principle. One question will solve and bind up this lecture. It is enough explanation about the process. So question is H2 gas plus I2 gas, it is forming 2Hi gas plus 3000 calorie. How to get maximum Hi? So Hi formation which direction? If equilibrium shift in forward direction. Hi formation in which direction? In forward direction only. So if equilibrium shift in forward direction, then only production of Hi will be increased. One by one we will talk. Concentration. So what is the condition? If you remove the Hi, then equilibrium shift forward direction, or if you increase the concentration of H2 or H2 or I2, then also equilibrium shift in forward direction. What is the second point? Pressure. If you increase the pressure, then here delta Ng is 0. That means no effect of pressure. Number 3, temperature. So if you increase the temperature, then reaction will proceed in which direction? Hi dissociate with the energy, backward direction. But we need forward direction. So if you increase the temperature, then production of Hi will be decreases. That means in that case we need low temperature for maximum amount of Hi. Inert material. Here also no matter, no effect of inert material, because 2Hi 2 moles, here also 2 mole, not Hi, 2 moles, 2 moles, delta Ng value 0, then equilibrium will not shift anywhere, so no effect of inert material here. So that is the condition for maximum yield of Hi. So that is it, children, about the Lee Chatelier's principle. Watch the video. If you like it, then share it also. Thank you.